We'll go over exercise C, where we will create new building geometry, integrate it into the model, as well as downloading some materials and integrating them into a new construction. I've already opened my exercise B2 and saved it with a new name as exercise C, so I'm ready to proceed to step 2. Download the file or navigate to the file in your synchronized folder. Noted in step 2, we're going to select File, Load Library, navigate to the location where you have that file. ASHRAE 2005 HOF stands for Handbook of Fundamentals Materials.osm, and open it. I'm going to click over on the right side here, pull, and that should be loaded. I'm going to go to the Constructions tab, then the Materials sub-tab, and I'm going to click on Library over here on the right, open up Materials, and then I'm going to scroll down to find Concrete Block with limestone aggregate 200 millimeters. That would be, there we go, this one. I'm going to drag it to the box here on the lower left that's dashed. That'll import it into my model. I'm going to do the same for insulation. It's going to be located alphabetically. I'll scroll down until I get to the insulation section. I want cellular polyisocyanurate. This one, the one with the gas permeable facers. I'm going to drag that in from the library as well. Then I'm going to go to My Model to actually look at the materials that I have in the My Model section. Oh, but first I skip past step 5. In step 5, I'm going to click over to the Constructions tab and create a new construction using the green plus sign. I'll name it New Wall. And then I'll go to the My Model tab on the right, under Materials, the right pane. I'm going to find Metal Decking, which is already in the model. Drag it over so that'll be the outside layer of the wall. Then I'm going to add the insulation material that I just added. It was in the library, but now it's in my model. There we go. Then lastly, I'm going to add the 1/2-inch gypsum that was already in the model as the inside wall material. So now I have a wall construction, or a construction that could be any surface I wanted to. Consists of metal decking on the outside, insulation, and then 1/2-inch drywall. Very simple wall, but it should work for our example purposes. I'm now going to go to the Construction Sets sub-tab and replace the exterior wall with the one I just created. That's going to be this one. It previously had an ASHRAE default wall. I'm going to go over to my model, scroll down until I see New Wall, drag it on top of there, and now it replaces that one. I'm going to save my file. The name of the construction set is 90.1 2010 CZ2 Office. I'm going to click over to the Facility tab and make sure that appears under my default construction set, which I can see that it does indeed. I'm going to go to the Loads tab next. Then lights definitions. I'm going to find the 90.1/2010 office open office lighting object. This one. Then I'm going to duplicate it by clicking the ×2 button. And now it's appended a 1 to the same definition name. Then I'm going to rename this Penthouse Lights. And I'm going to enter a new lighting power density of 0.8 watts per square foot. Currently I have the model displayed in IP units, or sorry, pardon me, SI units. I'm going to go to Preferences, Units, change that to IP, and enter 0.8 watts per square foot. And I'm going to save my model again. In step 10, we'll go to the Space Types tab here. I'm going to click on Office, Open Office Space Type, click the radio button, duplicate it with the ×2 button, and it's added a new space type called Open Office 1. I'm going to rename this, select everything, rename it Penthouse Space Type. Let's drop down here to the bottom. Back up at the top of the screen, I'm going to select Loads and locate my Penthouse Space Type down here at the bottom. I'm going to delete my existing lights definition by clicking the radio button, clicking the red X to remove that object. Then I'm going to drag my lights definition I created a moment ago, Penthouse Lights, onto the open box down here under Penthouse Space Type, and I can see now the Penthouse Lights came in with the name of Lights 1. Make sure you don't put it in the schedules column accidentally. I'm going to name this Penthouse Lights Applied. By default, it took the lighting schedule from my default schedule set, gave it a schedule of office building lighting, which will be fine for now. I'm going to save my model, make sure my weather file is applied, and then run a simulation to test and see if everything's working. The simulation completed successfully. I'm going to look at the errors. I have some warnings, but no severe errors, obviously no fatal errors. Those don't look too serious. So I'm going to save my model, open a new model in Open Studio so that one closes, and then go to SketchUp, the SketchUp plugin. and open the same model here. I'll start by putting in a new space. Here we're in step 14. Double click on the box to edit that space. Then I'm going to draw a rectangle across the top bar of the T. And push pull that rectangle up to make the space 12 feet high. I'll enter 12 apostrophe. My space is now 12 feet high. Just to be safe, I'm going to go ahead and save my model with a new version name. I'll call it version 2. And then I'm going to make another space in step 18 on the south leg of the T with a 15-foot overhang. I'll start by drawing in my space, make sure I'm snapping onto my horizontal plane. Make it the same height as the other space, and I'm going to push pull it out 15 feet. Alright, after creating that geometry, I'm going to save once again. And then I'm going to reopen the file, testing to make sure that the geometry shows up as expected. Oh, it caught the fact that a surface had gone in upside down, but that's been automatically fixed. So it should be okay to proceed. Save the file once again to lock in that change. Going on to step 20, I'm going to edit it and divide the surface here at the overhang. Because this surface faces outdoor air, while the surface back here is in contact with the ceiling below. With that selected, I'm going to use the inspector to give it a boundary condition of outdoors there, which it already picked up, so we should be in good shape. I'm going to give the rest of the surface, or the other part of the surface, boundary condition of adiabatic, also using the inspector. Oops. Sometimes this thing gets behind other windows and can be a little bit difficult to access. There we go. Give it a boundary condition of adiabatic. And assign a construction of interior floor. Render by boundary condition, check that those look right. This one's got outdoors as the boundary condition, this one has adiabatic. Oops, didn't mean to do that. I'm going to save the model. So presently, this surface is continuous, where the other surface intersects it. We need to divide that into multiple surfaces. We'll use the intersect command in this case to do that. I'm just going to intersect in the selection. Except the fact that it'll create new geometry. There we go. We're still rendered in boundary condition mode. So if I double click on that, you can see now it's still got an outdoors boundary condition, but it's divided into multiple different surfaces. Now I'll match the selection. Now when I double click, I can see that it's green, indicating that the surface is surface matched, as is its counterpart. I'm also going to give the floor of the other new space boundary condition of adiabatic. And give it a construction type of interior floor. Construction name, rather, of interior floor. You need to do the same to all the ceiling surfaces below. It'll be easiest if I hide these upper surfaces. Get better access to these. And then I'm going to go through and assign all of these individually. I'll do that by double-clicking on each one, selecting the relevant surface, applying the adiabatic setting, and I'm going to set these to interior ceiling. I'll pause the video while I complete the rest of them. Alright, I have one last to complete. Select the surface, give it an adiabatic boundary condition, making sure to set the construction properly, and those are all complete. That adiabatic boundary condition means there won't be any heat transfer through those surfaces, which is a valid assumption if the thermostat set points are the same on both sides of the surface. In step 24, I'm going to unhide everything so my surfaces reappear. Then I'm going to draw a rectangle over the southernmost face of the penthouse and use the offset tool, which I can easily undo if I make a mistake like that. Offset 18 inches inwards. And double click my space and trace that rectangle within the space to draw a window. And test to see if that worked by deleting my construction geometry, and then I can see my window is now in the model. I'm going to do that same process on the northernmost face, making sure to snap to the plane of that face. Select the surface created, offset 18 inches, double click, trace over that, delete the SketchUp geometry, and then I can see my OpenStudio geometry has been created properly. Alright, going on to step 25, I'll select the southernmost leg of the T, and then use the attributes tool to set the following. I'm going to apply my new penthouse space type that I created. Create a new building story. Construction set won't change. Create a new thermal zone for that space. I'm not going to change the ideal load status. And I'm going to select my OpenOffice thermostat. I'll go ahead and render by story. You can see there's only a slight difference between these two spaces, but this one is a little bit more green. I'm going to click on that and see that it called it building story 1. Look at my other stories that were created automatically when I created the other one. I called them story 1, 2, and 3. I think it'll be a little bit more intuitive if I rename this one story 4. So by renaming it here in the context of this one space, it'll rename the story itself. Then I'm going to use the attributes tool, having selected the northernmost bar of the T, and I'm going to give this one the same settings. I'm going to give it the pinhouse space type. Now I'm just going to select story 4, which is now a part of. And I don't need to change the construction set. Thermal zone. We'll create a new thermal zone for that one. And apply the OpenOffice thermostat as well. Alright, you can see now that that new story is showing properly. I'm going to save. Open a new file to close that model, and go back to OpenStudio. I've opened the file once more in the OpenStudio application. My weather file is still applied here properly. And now I am going to apply my HVAC measure once more because we added the new story. I selected Apply Measure Now. It'll take just a moment for that to come up. Under HVAC, and go to Whole System. Select the same one we used previously, ASHRAE SYS for System 7 VAV Reheat. Then Apply Measure. It'll run for just a moment. It says it started with 3 air loops, 3 plant loops, 30 zones conditioned. I now have 4 air loops, 3 plant loops, and 32 zones conditioned. Noted that the service water heating loop is used for heat reclamation, so it's not going to be deleted. So I'll accept those changes. It sounds like it did what I needed it to do. After that, we'll go to the OpenStudio Results tab and apply the OpenStudio Results measure. Then run your simulation and record the new EUI and record it in the class spreadsheet.